So now we're going to pull together all of our skills to solve general systems of linear equivalences in one variable. Some of the bases might be coprime, some of them might not. Let's just see what happens. Here is our first example. Find the smallest positive solution or show that there is no solution to find. We have three equivalences. We want to find an x that is equivalent to 2 mod 5, 1 mod 8, and 5 mod 12. Now our three bases are not relatively prime to one another, but 5 is relatively prime to 8 and is relatively prime to 12. Therefore, whether a solution exists or doesn't entirely depends on whether I can find something that solves these two simultaneously. If a solution here exists, there is one solution modulo the LCM of 8 and 12. And the LCM of 8 and 12 will definitely be relatively prime to 5, so I'll then have two equivalences with relatively prime bases, and then I know solutions exist. So whether or not solutions exist entirely boils down to whether there is a solution to the two equivalences whose bases are not relatively prime. However, let's just check. Do there exist solutions to both of these simultaneously? So I need to compute the greatest common factor of 8 and 12, that's 4, and then ask, is 1 equivalent to 5 modulo that number, 4? Yes, 1 is equivalent to 5 mod 4. So there are solutions to this pair. There will be a unique solution modulo the least common multiple of 8 and 12. Since that's definitely relatively prime to 5, I can then just claim there is a solution overall, and then I can try to find it. Now, just using the brute force technique on the previous slide, I just list out 1, and then I start adding 8, and I keep checking mod 12 until I find a solution. 1 is not equivalent to 5. Add 8. 9 is not equivalent to 5. Add 8. 17 is equivalent to 5 mod 12. So these two equivalences here can exactly be replaced with just a single equivalence, x equivalent to 17 modulo the least common multiple of 8 and 12, which is 24. So I still have this equivalence here to worry about, but I've replaced these two with a single equivalent statement. And now I have relatively prime bases. And we in fact see pretty quickly 17 is clearly the smallest solution to the second one, but that's already a solution to the first one. If nothing else, you can just apply the Chinese remainder theorem and use the algorithms developed in earlier lectures. So x equals 17 is one such solution. However, that actually tells me that all solutions must be equivalent to 17 mod 120. And 17 is the smallest positive integer that is equivalent to 17 modulo 120. So we found the smallest positive solution, and we had to combine techniques from various places. Let's do another example. Again, find the smallest positive solution or show that there isn't one to find. We have three equivalences, 2 mod 10, 4 mod 6, 7 mod 15. No pair of bases are relatively prime to one another, so let's just do this by attacking one pair of equivalences and seeing what happens. 2 mod 10 and 4 mod 6. So what we have to do is check, are there even solutions to find? Yes, the GCD of 10 and 6 is 2, and 2 and 4 are equivalent modulo 2. So now can we find a solution to both of these now that we know there is one? So we start with 2 and we keep adding 10 to it, and I simply check modulo 6. Is 2 equivalent to 4 mod 6? No. Is 12 equivalent to 4 mod 6? No. Is 22 equivalent to 4 mod 6? It sure is. So 22 is a solution to both of these. So now instead of having these two equivalences, we have solved that both of these are solved exactly when x is equivalent to 22 modulo the least common multiple of 10 and 6, and that least common multiple is 30. So these two here, I replace with one equivalence like this, and now I start adding the next one in and ask, well, now I've got two equivalences. 22 is equivalent to 7 modulo the GCD of 30 and 15. So there are solutions, and there is one solution modulo the LCM of 30 and 15, which is 30 again. So there's only one solution mod 30, but it has to be 22 mod 30. So there's only one solution modulo 30, and it has to be 22 mod 30, so hopefully 22 mod 30 is the only solution. And indeed, 22 does solve this equivalence as well. So x equivalent to 22 mod 30 actually describes all solutions and is already the smallest positive solution, 22. Now let's take a look at a third example. Find the smallest positive solution to the following system or show that none exists. Here we have 4 equivalences. X should be equivalent to 2 modulo 12, 4 mod 14, 8 mod 18, and 10 mod 20. We're just going to go pair by pair and see what's going on. 2 is equivalent to 4 modulo the GCD of 12 and 14, just looking at the first 2 equivalences. So since that does work out, that first pair of equivalences has a single solution modulo the least common multiple. And the least common multiple of 12 and 14 is 84. So we're just going to list out solutions to the first equivalence. What are some numbers equivalent to 2 modulo 12? 2, 14, 26, we're just adding 12 every time. 38, 50, 62, 74. If I were to keep adding 12, I would go beyond 84. So out of this list, the only thing that is equivalent to 4 modulo 14 is that last one, 74. So out of the possibilities, there was one option that solved 2 mod 12, but also solved 4 modulo 14. So we can replace that pair of equivalences with just one. X should be equivalent to 74 modulo 84, but also 8 mod 18 and 10 mod 20. So we move on to the first pair of this new system. And we check 74 is indeed equivalent to 8 modulo the greatest common divisor of 84 and 18. So therefore, that pair of equivalences has one solution modulo the least common multiple, which is 252. So we list out solutions to one of them. Some numbers equivalent to 74 modulo 84. 74, keep adding 84. 158, 242. And 242 is equivalent to 8 modulo 18. Therefore, this pair of equivalences, x equivalent to 74 mod 84 and 8 mod 18, can be replaced with just the one, 242 mod 252. Now we just have a pair of equivalences, 242 mod 252 and 10 mod 20. So we check once more. 242 is equivalent to 10 modulo the greatest common divisor of the two bases. So there is a single solution modulo the least common multiple. And the least common multiple of 252 and 10 is 1260. So we list out solutions to one of them. Some numbers equivalent to 242 mod 252 would be 242, 494, 746, 998, and 1250. But that last one is the only one that is equivalent to 10 modulo 20. So overall, our entire system has now been reduced to one equivalence. X should be equivalent to 1250 modulo 1260. And we were asked to find the smallest positive solution, and 1250 is indeed the smallest positive integer, which is equivalent to 1250 mod 1260. So the smallest positive solution to all 4 original equivalences is 1250.